Good afternoon. Thank you all for coming for this presentation after lunch especially. So, I would like to start with my experiences on security design or data lake architecture. Like today, nowadays, we are shifting the left for the security actually. Like earlier, security was an afterthought. Now we want now we are moving towards, the industry is moving toward, inching towards adding the security as a requirement, especially after data is moving towards the cloud. So, as part of this, in the today's agenda, we will start with the what we have to be, what we have to do in the design approach, and what are the steps we have to achieve, we have to follow to achieve secure by design. And then we will explore the benefits, and then we will take out the principles. First of all, we will see the steps, and with the steps we will try to marry with the principles, key security principles we have, and then add to the look at the tools at our disposal, no matter what cloud is, but today we will look into the Azure cloud. And then now after doing the design and the development, we will see we will check the stride, one of the threat, we have many threat modeling tools actually, many threat modeling concepts. I will take stride as a threat modeling concept, and we will look into that, how we can do the threat mitigation by using the threat model. Now then we will automate the security integration into Azure DevOps, with DevSecOps, because we wanted to identify the threats. We wanted to break the break our Lakehouse in the development environment, try to break the Lakehouse in the environment as much as possible actually. So, and then we will discover the methods to ensure the compliance between the regulatory and security standards. So, earlier 15 years back, when I used to code in in the on-prem machines, when I asked for the security, when I asked for the security is part of the quality actually, the quality guy used to come and he used to say, hey, you have run this, run this, etc. And then he used to go through it. It's an afterthought actually. And it was a perimeter focus, whether you have covered everything or not. I think it's derived from the human tendency where after writing a letter you put it in the envelope for the security. So in that way we were using the security earlier. And we used to do manual security reviews. And the data and security teams used to work in silos actually, and at the last moment, at the nth moment, we used to get a lot of surprises while working on it. Hey, I wanted this to be accessed, but it's not getting accessed, or the vice versa, which is even more, even more threatening actually. Now, this secure by design approach is we'll first start with the security ideas in the architecture level, and then we follow the zero trust model, which is the base principle of the security model, where not giving access is not giving any access is better than giving unwanted access. And we will do the automated security testing and compliance checks, and we will do the it will do the proactive threat modeling detection. So, how to achieve the secure by design? Initially, at the start of the project itself, as a security architect, you have to start collecting the requirements, what are the business requirements, what is the data which is going to come to my Lakehouse? Is there any compliance data like GDPR, which is European standard, or PII data, or something else which is going to come? Is there any data residency restriction? Like for example, Europe doesn't allow the GDPR data to come to US, so like you need to create the whatever infrastructure in European regions only, not in the US region. Now, after identifying that, like you need to sit with the, we used to sit with the customer and ask him to classify the other than the default data, PII data which is coming, we used to like, for example, the industrial data, we used to sit with the customer and classify the data accordingly, like whether it is confidential or whether it is restricted, whether it is public or anything else. Now, once you classify the data, like once you put the data into the lake, so you may get the threats actually. Like so, we try to identify what would be the potential threats in the Lakehouse, which is going to come, like by using the stride mode, like and those threats we identify, which are going, we anticipate those threats and try to map those threats to the controls which we have in Azure, which could mitigate those threats. And so like that's not a single process, like that's a repetitive thing actually, like so it's not like at one shot you will solve all the security issues. So like as and when the Lakehouse data is growing, as and when the customers are the users are joining in the Lakehouse, you may get more and more security vulnerabilities actually. So that will be the repetitive thing. So what we need to do is those repetitive things we cannot do it it's difficult to do it manually. So what we need to do is like we need to automate it. So how we automate it? Like we create a infrastructure, code infrastructure using Terraform, or like in case of Azure, it is an ARM template and Terraform for creating those security controls along with the Lakehouse architecture actually. What I meant to say is like when you are creating the Azure Lakehouse infrastructure with your DevOps pipeline, try to add the security controls also along with that actually. And last but not the least, continuously monitor actually, like for the security measures for compliance. Now, let's go through the core principles of security actually. Like one is defined by the industry standards. One is first they say is zero trust policy. Like it's better not to give the access to anyone than giving the unwanted access to all actually, or someone. So you have security controls at you can have security at various levels. For example, you can have like the data is like there is a constant movement of data in the cloud actually. So you can have security at different levels. For example, you can have security at the network level, security at the data layer level, security at the application. You can apply security at the application level, and and like then ensure like least privilege access to the like we have a beautiful concept called role-based access control, where you can control the resources based on the user role actually. For example, like if a user is part of, for example, I am a data engineer and I can transform the data. But I'm a data engineer, I can transform the data, but I need PII data to be transformed. So I can, so I have to have an access to the PII data. So all the data, like you can create a role and add the users into the role and give access to the PII data for the transformations. In case of analysts, you can control the data based, like you can control the data, you can control the resources based on the role-based access control. Now, start integrating the monitoring tool across all the environments actually, like in the dev environment and in the dev QA and prod environment. So now we have got the core principles. Like let us see what in the last slide I have mentioned like there are we can have the security at various layers and various levels. So like these are the some of the controls which act as a security guards for the in those layers. For example, like in network layer you have a Azure private link, where Azure private link is the one like where your data goes through only the Azure Azure networks and not it will not go through the internet actually. So it will be the private link for you for your and you have Azure firewall which stops the incoming data access actually from the internet. And we have DDoS defense defense to the denial of service protection, where like a person can send multiple requests and bring down the service. So like we have a defense protection like which safeguards the traffic. In the identity layer we have Microsoft Entra AD. It is like a Azure. It is a Azure Active Directory where like your user like as you are a user like you can it identifies it identifies and authenticates the user actually Entra AD. And role based access control what we have seen. And the infrastructure layer we have Azure policy and role based access layer for the governance. And in the data layer we have data encryption, you can encrypt the data and decrypt the data for so that the user cannot tamper the data. And you can do the row level and column level security for the data, so that the user like if it is a structured data you can do row level and column level security, so that the user based on the role like he can access the columns actually. And monitoring layer where like you will be constantly monitoring, you have a a Defender and Azure monitor logs, like where you can monitor the actions of the user, actions of the user and actions of the resources actually, like what kind of it's basically the audit log of what's happening. Next, how do you detect a threat? So there are a couple of frameworks called Stride, Mitre, etc. So Stride categorizes, Stride is nothing but it categorizes the threats into 6 types actually. As for spoofing, spoofing is like somebody can impersonate himself and authenticate access the data. And T stands for tampering. So anybody can access the data and modify the data. R stands for renunciation, where a person says if I access the data, if I'm a hacker and if I access the data, then I can say hey, it's not me actually. If I don't have a proof that that I have accessed the data. Information disclosure. This is the biggest threat, where a person can, a user or a hacker can take out the data from your Lakehouse and use it actually. Denial of service and elevation of privilege. A user can act as an administrator and access the data which is not intended for him to access to actually. Yeah, these are the classification of the threats. The Stride threat model has been identified actually. So this threat, when you use this threat model, there is a beautiful tool in Azure called Azure which is given by Microsoft. It's a free tool where like you can take your architecture, take your flow diagram and identify the and put that flow diagram in that and assess the threats actually which is coming in, for those. Now, what like I try to map the threat and it's like what are all the Azure mitigations and the Azure controls which we can use to mitigate the threats, spoofing, Azure, spoofing is impersonation where like Azure AD is nothing but your Active Directory of the company where all the where all the company users, where the employees are registered in the registered for authentication. So what it does is like, for example, whenever you try to log in as a different user, like it goes to the Microsoft Azure AD and tries to authenticate it. You can add the authentication level with a multi-factor control where like you can get a notification, you can get a push notification to your device and you can accept that tag. So and you have private endpoints where like the external user cannot enter into the network and access the data. Yeah, tampering with the data. One thing we can do, the one mitigation is encryption of the data. Encrypt the data at the rest and encrypt the data at the transit actually. Data encryption at the rest and data encryption at the transit using the customer managed keys actually. Also like what we have done is like if somebody manipulates the data or tampers the data, you can have in case of storage layer you can add the soft deletes where like you can recover the data. And yeah, so reputation is like you can have an audit log where like to identify like monitor and activity logs and diagnostics to identify like what kind of activity has happened on which resource and like whether it is a security threat or whether it is a normal as usual data. Yeah, so yeah, information disclosure like one is private endpoint. If you create a private network within yourself, you cannot, without the internet access, like you can the information cannot be accessed by the hacker outside. And like the other things are like at the data layer, like you can use masking if you want to. If the analyst doesn't want to see the data. Yeah, denial of service, too many, if you get, if the hacker sends too many requests, so it makes the service to break down while handling the requests actually. So it will not, the service will not be available if, basically he is trying to keep the, bring the service down actually. So what there are the tools like other DDoS protection where like you can control the denial of service by whitelisting the IP addresses of where from where the data has to, from where the access has to go. Yeah, elevation of privilege, like you can use privilege RBAC again, role based access control where like managed identities can be added to the roles and the for the resources it is managed identities, for the users it is like user groups you can add to the create the roles and add the user groups and the managed identities in the roles actually. So what are all the steps to create straight threat modeling actually, like so you identified like okay, so I may get some seven types of threats in my Lakehouse. So how do I know like whether all the threats are valid, like in all the threats are valid to my Lakehouse, or like in which area we get what kind of threat? So like how do I identify? The first thing I need to identify is like to have the data flow diagram. So like for example, like in an architecture, like you have to, in your Lakehouse, you have to see like where the data is coming from, what the data, what kind of transformations are being done on the data, and like who is accessing the data, what kind of what resource is accessing the data. In case of Azure, it is like Azure Lake. Azure Storage Lake and Azure Data Storage Lake and Azure Synapse Analytics and servers actually. Like these are the three things, mainly these are the three things which can access the data, and externally the data can be accessed by Power BI and the source also can access the data by sending the data. So the main thing is like first we need to have a data flow, like how it is going, like what are all the, like where the data is getting transmitted, data is in transit, in which place data is at rest, and which place the transformations are going on the data. These are the three things which you need to know actually, like how the data is going out. So like as a task actually, like I have created a simple data flow for the Lakehouse to identify the threat modeling. So here, like first step is data is getting ingested into the Azure Data Lake, okay, and Azure Synapse Analytics is doing the curation aggregation, and it is storing the data into the data lake again in the Delta format. And the Azure serverless SQL service is creating the metadata on the Delta tables which are created, like creating the external tables for the people, for the external users to use. Also, like it acts as a SQL engine for the external users like Power BI and all to use. Okay, this is like when I asked for the data flow diagram from the architecture team, like this is the bare minimal data flow diagram I got. So what should I do? Yeah. So the first step here is give preference to the network layer, identify the stride places where it is happening. So there it is happening, there tampering can happen, information disclosure can happen, and denial of service can happen. Here also tampering can happen, information disclosure can happen, and denial of service can happen. And here tampering and information disclosure can happen. So like here, like when the data is being ingested, like for example, like if you take the ingestion part, when the data is being ingested, so the data can be tampered in the data transit layer, or source, like that is the tampering part, like information disclosure is like source anyway has the control on the Azure Data Lake because it is ingesting the data into the Azure Data Lake. So it can exfiltrate the data also, exfiltrate other data also. So that way information disclosure will happen. And denial of service, you can send too much of data to the Azure storage layer. Azure storage layer actually, like so that the service is not available. So what do I do? Like the next is like let's try to we have mapped this to the network layers actually. Like what will happen to these resources? Like we need to identify what are the threats which we get in the resources. So in these resources we can have spoofing can be done by accessing this resource directly, and accessing the Azure data lake directly, and data tampering can be easily done, like if you have access to the Azure data lake, and you have redundation where if you don't have the audit logs or anything else which is which are monitoring the Azure data lake, you will not be able to see like who has done what. And information sharing can happen as is it obvious, and and denial of service, and like you can get the elevated access, and like you can exfiltrate all the data from there. In the same way, like if in the data, in the Synapse analytics also, like yeah, you can in the you can do spoofing, you can do tampering of the data by extracting the data, and yeah, like if you don't have Azure monitors watching this resource, like you don't know like who has done that, who has tampered the data or anything else, and information disclosure will happen, and yeah, like you can send the too many you can call too many times the pipeline to run and bring the service down. Now the first thing I have to do, now we have, so the Power BI is the external layer which will be taken, is the external one which is not part of my Azure data lake. So first what we have to do is we need to identify the boundaries. So actually at what, like in this diagram, like at the till what point, what are my boundaries, till what point I can, I have to take care of security. So that you need to identify. So first what I did is I identified, okay, this is my Lakehouse zone. Like these are the places where I need to have a secure, I need to secure the data and the resources. So the first thing I did is, so you have create a private link because you have a network layer where like you can avoid lot of spoofing or tampering of the data if the users outside doesn't have access. So you can create one private link layer. Okay, in this not the private link, this is Microsoft virtual network layer, where like you have in your subnetwork you have some like a list of machines, virtual machines, where you can deploy those resources in those virtual machines, or you can, if it is a service, like you can point out that like you create the service at that level actually. Next thing is create a private link to the Azure storage layer. The curation and aggregation, now it is safe because like you have created a private link which doesn't go to the internet to access the storage layer actually. You are creating the private endpoint, and in the same way in the SQL server also, like you have created the private link. Next, like what happens if the third resource comes and access the data? It can access the data in the Azure storage layer. So how we can avoid is like you need to have a resource-based access control. So how do you give the resource-based access control? So you have to have an identity for the resource managers. So Azure provides identity to the resources, like here the Synapse Analytics is like a user for you, is like a user actually, like me, Synapse Analytics is a tool which is accessing the data. So it provides the identity to the, identities to this. So these two can, these managed identities are given corresponding corresponding things actually, corresponding access in a role-based access control. Yeah, and you are storing these identities in the key vault to get the secrets. So now this is free. So yeah, so data can still be exfiltrated because the data ingestion layer has the outside layer has the access to the data ingestion. So what we did was like we created a private link, we created a landing zone and a private link between the data ingestion layer. Yeah, so you can use Microsoft Defender like for all these to read, to identify, like to monitor to all the resources to monitor the things actually. Yeah, so you can automate the Lakehouse by Lakehouse architecture with infrastructure. Now this is a repetitive thing, like you cannot do it at one shot actually, like you get more requirements, you get like more resources to act actually. So that needs to be automated actually, like these security controls need to be accepted. Like this is a manual thing which we did, so we need to automate it. So we have taken back this diagram and implemented the scripts to deploy this structure actually automatically. So so this will reduce the human errors actually, like I might have put all the controls in the developer environment, and in the test environment I might have forgot, in the production environment I have forgot one of the control, and then it would lead a disaster actually. So yeah, so now so you have got so you are able to do that now, like you have to do as we discussed earlier, we have to do the threat analysis every continuously, like it's not like you have done it and closed it actually. So what that also has to be automated. So what we did is, like we have created a Azure DevSecOps CI/CD pipeline where like the stride threats are automated, like we will try to infiltrate into the data and see like whether we are able to read the data. We try to access the resources and see whether we are able to access the resources with the elevated privileges, etc. automatically, like by using the stride test tools. Yeah. Then then once it is done, like continuously verify it with the Azure security baselines actually, like to see like whether you are able to adhere to the Azure security baseline. Like for example, if it's a Synapse, like you have to close all the public links, you have to only have the private link, etc., etc. So you have a document of Azure compliance and cloud infrastructure security compliance documents actually, whether you are compliant to that or not. You need to. This is for our good only, because like key takeaways is like, so we have discussed, we have talked about the like we have started thinking about the security at the requirements level actually, and we collected the requirements in parallel with the normal data architects, and we leveraged most of the Azure built-in features. And so we have added the continuous monitoring in the development environment. I have deployed everything in the development environment, and we are continuously monitoring it actually to see many more threats, any more threats are going to come actually. Thank you.